Welcome back, mathematicians. In this video, we are going to learn about the inverse tangent function. So first, a little bit about inverse functions. In order for a function to have an inverse function, it first must be one-to-one. As we can see by the graph of the tangent function, it fails the horizontal line test, which means it is not a one-to-one function. As a result, what we do is we restrict the domain of the tangent function to be from negative pi over 2 to positive pi over 2. This is not inclusive because pi over 2 and negative pi over 2 actually represent undefined angles for tangent, and on the graph is represented by a vertical asymptote. Our range, however, is still all real numbers. This gives us the definition of the inverse tangent function, which is y is equal to the inverse tangent of x if and only if x is equal to the tangent of y, where x is between negative pi over 2 and pi over 2, and y is an element of the set of real numbers. Let's now use that information to find the exact value of each of these inverse tangent functions. First, I'm going to start by letting this inverse tangent function of 1 be equal to a variable theta. I use the variable theta because it represents an angle, and the output for the inverse tangent function should be an angle, whereas the input is a ratio. I'm then going to take the tangent of both sides, so I get 1 is equal to the tangent of angle theta. I'm asking myself what angle, when evaluated for tangent, equals a ratio of positive 1. You can use your unit circle to evaluate this, but it's a little more challenging than sine and cosine, since tangent of theta is equal to the ratio of y over x. Instead, I'm going to go ahead and draw myself a quick picture. We need to keep in mind that theta must be greater than negative pi over 2, but less than pi over 2, which means my terminal side for this angle should be in quadrant number 1 or quadrant number 4. Because the ratio is positive, I'm going to put the terminal side in quadrant number 1. I'm now going to draw myself a triangle. Because the ratio is 1, it means that the adjacent side and opposite side, or the y-coordinate and the x-coordinate, will both be the same value, so I'm going to choose 1. Using the Pythagorean theorem, I know that this hypotenuse or radius is a value square root of 2, which means that this angle theta would be equal to pi over 4. Moving on to the next problem, I have inverse tangent of negative square root of 3 over 3, and I'm going to let that equal to the variable theta. I'm now going to take the tangent of both sides, so what I get is tangent of angle theta is equal to negative square root of 3 over 3. So again, you could use the unit circle, but it's a little more challenging because you're looking at the ratio of y over x to figure out which one of those ratios will equal negative square root of 3 over 3. So what I'm going to do is use a picture here. But before I do that, I recognize that negative square root of 3 over 3 is the result or the ratio after it's been rationalized. So I'm actually going to unrationalize that denominator, and what I get is negative 1 over square root of 3. I'm now going to put the initial side on the coordinate plane, and because again inverse tangent is defined for quadrant 1 and quadrant 4, and because the ratio is negative, I know that the terminal side should be in quadrant number 4. I'm now going to draw or complete this triangle, and I have the y-coordinate as negative 1, the x-coordinate as square root of 3, which means the hypotenuse must be 2. This reference angle here, based on this triangle, will be equal to pi over 6. Now, because of the fact that I know that theta must be greater than negative pi over 2, but less than pi over 2, my rotation for quadrant number 4 must be clockwise. So therefore, theta must be negative pi over 6. If you were to choose the coterminal angle, which would be 11 pi over 6, this is not within the acceptable restriction of theta, so it would be too large, and that's why that is not a solution. All right, guys, good luck.